common and cheap energy source for microgrids is photovoltaic. Photovoltaic is often combined with batteries to match the power generation and demand. In this video I show you how to plan and dimension a microgrid with PV panels and a battery using nPro. Hi and welcome to this nPro tutorial. I'm Marco, and in this video we will go step by step through the dimensioning process of microgrid with PV and battery. Let's dive into it and see how that works in nPro.
So on the start page of the tool, I click on Energy Hub. Then I select a project template. It's not really important which you choose because you can modify the system structure afterwards. In this illustration here, I activate the electricity demand, the battery, as well as the connection to the electricity grid. I deactivate the wind power, the hydrogen technologies, and now I will modify the battery parameters. I will make sure that the battery is really selected by the optimization and decrease the costs of the battery, increase the lifetime. For this example calculation here, we choose the electricity demands, the example demands that is in nPro, but of course we could here upload our own demand profile. I will increase the supply price of the electricity grid to 30 cents per kilowatt hour, and I will decrease the feed-in tariff to make sure that the battery is selected and sized in a reasonable manner. We see here that the battery has a capacity of 1200 kilowatt hours and the photovoltaic has a capacity of 1550 kilowatt peak. Of course, we can change the dimensioning here. I will increase slightly the battery and I will also increase the photovoltaic capacity and then simulate the system operation. And with the results of this calculation, we can then see how are the components really operated over the year. We have first an overview. We see that most of the electricity comes from the PV. And if we go with the mouse over the lines, we can also see the quantity of the electricity or the energy flow. On the bottom, we can visualize the operation of the system. So we can click on heat map and then we see the electricity generation over the year. So the hour of the year plotted over all days of the year. And then in summer we can see, okay, here we have the highest or the largest electricity generation. We can also visualize the operation of the battery, and that is the state of charge here. So we see that in the afternoon hours or evening hours in summer, the battery is charged and then discharged over the evening and night time. In winter, we only have the case that the battery is charged in a couple of days here. And then in some cases, the battery is discharged over the entire night. Probably that's maybe it's a weekend where the electricity demand is not that high. And we can also visualize, for example, the charging power. So what we already saw in the afternoon hours, the battery is charged and the discharging power can also be visualized. We can click on summary and then we see some global KPIs, for example, for the electricity generation. We see that in this case 84% of the electricity demand comes from the PV and only 16% have to be imported by the electricity grid. We have an overview over the emissions and the primary energy. The specific factors for the emissions and primary energy can be changed in the settings of the optimization. Then the economic results. In this example here, we have a system that is profitable, so the revenues are higher than the costs. We have the cash flow table here. The net present value is positive after 20 years. We also have visualization of the net present value over all years of the system. We have the investments in one table, another table with the energy costs, so how much electricity did we import from the grid, the operational costs, and we have the revenues. And here we can change the revenue for the electricity demand. So the microgrid operator will receive a revenue for every kilowatt hour that the electricity demand is covered. So if we change this to 10 cents per kilowatt hour, then the profitability of the system will go down. Right now it's not profitable anymore. And if I increase this now by 1 cent per kilowatt hour step by step, we can see how the net present value increases and the profitability increases, and this would be the setting where we just reach the profitability of the system. So that would be the case actually at 20 cents per kilowatt hour. The user can also download now all the results from the summary, from the economic results, and also all load profiles and all operation profiles with an hourly resolution of the battery, of the wind turbine, of the electricity grid import, and so on. And this can be helpful if you want to make further analysis or your own plots. For this, you can use the download option for the Excel file.
If you have any questions or remarks about this video, feel free to leave a comment. If the video was helpful for you, please give us a like and subscribe to our channel. Thank you for your interest and see you next time.